In this video, we're going to carry on looking at factorizing quadratics, and this time we're looking at the difference of two squares. So hopefully you've already watched the first video in this series. I want to take us back to just the reverse process, which is expanding again. And if you remember, if we expand something that looks like this, then it is going to be x squared plus 6x plus 8. And you should remember that I multiply these two numbers to get the term on the end, and I add those two to get the coefficient of x. So that's how we factorized simple, straightforward examples. Now, what about a different one? What about if I said x plus 8, x minus 8? Now, if I expanded that, what would happen is I would get an x squared plus 8x minus 8x and a minus 64. And what would happen is that these terms here, look, cancel out. 8x minus 8x just disappears. It's nothing at all. So this is just x squared and a minus 64. So there's a relationship going on here when these two numbers are the same but with opposite signs. Let's see if the same thing happens again. If I had x plus 4, x minus 4, and expanded it, it would just be x squared and a minus 16 for exactly the same reason. So we can look at this pattern and carry on through and find really helpful things if we see a quadratic in this sort of format, right? So that is with no middle term and a negative at the end, right? Okay, so all we're going to have to do is, well, if we square root this, we're going to get these two values here. And if we square root that 16, look, we're going to get these two values here. Okay, so let's have a look and see if we can use this to factorize some things here. So let's take a look at A. Well, first thing we're going to do is we're going to look at this x squared and square root it, and that is just going to be in here. Then we're going to look at this 9 and we're going to square root it, and we're going to put that in there. And of course, one has to be a plus and one has to be a minus. And let's just check this. If I do x times x, yep, x squared. 3 times x is 3x. Minus 3 times x is minus 3x. And 3 times minus 3 is 9. These cancel out. Yep, this is correct. We do get x squared minus 9. Okay, let's look at that second example in B. So if I am going to square root 4x squared, I'm going to have 2x. So I'm going to write that in first. If I square root 25, I get 5. So we're going to have 1 is a plus, 1 is a minus. And there is my solution, 2x plus 5, 2x minus 5. This is a really simple technique once we've spotted that we can have square numbers in my expression. Okay, now then, let's try a few more challenging ones. What about if I said 100 minus 9x to the power of 4? Could we do it the same here? Well, yes, we could. Both of these numbers are square numbers, and there is a negative sign between them. So that means I could factorize it. If I was going to write this out, the square root of 100 is 10. The square root of 9x to the 4 is 3x squared. So I can write that in as well with a plus and a minus sign, and we are finished. This is a quick technique that helps us to factorize particular types of quadratic. Now, we'll do one more. What about something like this? 50 minus 18x squared. Could this be done? Well, on the surface, no, because it looks like we don't have any square numbers. But what we certainly could do is we could take out a factor of 2 from both of these two things in a typical linear kind of way. So I could definitely write this as 2 lots of 25 minus 9x squared. That would be true. Now that I've done that, actually, hang on a second, I do have a square number and I do have another square number. So maybe I could use this after all. I can leave that 2 exactly as it is and replace that single bracket with the double bracket by writing 5 at the beginning and 3x at the end, the square root of those two red highlighted numbers from above. One has to be a plus, one has to be a minus, and actually I have been able to factorize that. So on certain occasions, just look to see if you can manipulate the expression to bring out the square numbers, and then you can follow through with this difference of two squares process.